Welcome everyone. I am Jay Surya, a data scientist and data analyst, and I'm a Microsoft certified AI engineer. And here I'm excited to guide you through this hands-on masterclass on data science with Python. So today we will keep the things practical and grounded in the real use cases, so that you can connect the concepts with that actually happens in the business, right? So whether you are a completely new or having tried to learn before the data science, so this session is designed to build the intuitions first and the syntax next, right? So we will unpack what data science really is and why it is so valuable across the industries and how the Python statistics and machine learning fit together, right? So my goal is to help you people to think like a data scientist, asking the right questions, breaking the problems down, and choosing the methods with the purpose, right? So please feel free to interrupt with the questions. So interactive learning will always beats the passive learning listening, right? By the end of the this masterclass, I have planned to conduct the masterclass for the 10 days, so that you will have a clear mental model of the field and the roadmap to keep the progressing after the session, right? So here we have the quick introduction to set the expectations and build the context. So I have worked across the analytics and the AI projects that spans exploratory analysis and dashboarding and production ML, right? So my teaching style, which emphasizes the clarity and practicality, so you will see the concepts tied to the real business decisions. And I encourage you to connect with me on the social platforms. I will be dropping the uh, the social links, social applications links like in LinkedIn, and we have the learning platform as well, and we have a JAI community, so where you can get the real-time updates and the daily updates, and you can able to learn through the daily messages. You can learn Python, you can learn statistics, you can learn all the real time on demand technologies. So here this master class is designed to move you from the theory uploaded to applied the understandings. So we will focus on reasoning over the road memorizations. So why we choose these certain methods, so what assumptions they make, and how they translate to outcomes. So you will see the examples from the real domains like retail, finance, and the product analytics. So you can map these techniques to decisions such as pricing, churn detection, or feature prioritization. Right. So we will keep it interactive. Short, we will be having a short demos and quick polls, and we'll be discussing the prompts. And so these goals is not just to teach, the terminology, but it can help you to evaluate the trade-offs. So like the accuracy versus interpretability, and the short-term versus long-term values, and the prototype versus the productions. So by the end, like you should feel confident about what to learn next, right? And how to apply it on the work or in a project. So it should be, career focused guidance. So who should attend these masterclass? So this session is intentionally beginner friendly and cross-disciplinary. So if you are a student, a career switcher, or a non-programmer, exploring the data, or simply an enthusiast, right? So you are in the right place, and we will steer the clear of heavy math proofs and focusing instead of on intuitions. Like we'll be focusing on intuitions, visuals, and the practical steps. So if you have the domain knowledge like marketing, operations, finance, or healthcare, that's actually an advantage for you. So these are all the things that will where the data science thrives on the domain context, right? So you don't need to be a coder today, or else no. We will be showing you the how the Python fits in, and what to practice later, right? So these are all the only prerequisites are curiosity and the willingness to engage. So if you can frame a question clearly, we can usually translate it to a data approach. So by the end of the session, you will be able to explain what data science is in a plain language and describe how data generates the business value and identify where the companies use data in their daily decisions. So you will be gaining a foundational sense of how Python, statistics, and machine learning connect the Python from the the implementations, statistics for the inference and rigor, right? So you will also leave with a concrete next steps roadmap, specific topics to learn, and practice exercises and portfolio projects, where I will be giving you the portfolio projects where you can build and push it on the GitHub. You can showcase that projects as you did, the previously, where you can showcase it as an experience, right? So first, we landed up what is data. So let's ground ourselves. Data are raw fact, numbers. It can be a numbers, it can be a text, images, clicks, sensor readings, right? So by themselves they are not meaningful, so they need a context and processing. So data is everywhere. The apps log interactions, business captures the transactions, and the devices stream the telemetry, right? So in data science, we transform these raw materials, raw elements into signals that answers the questions. A crucial skill is recognizing the data types early. So it can be a number, a numerical versus categorical, structured versus unstructured, static versus time series. So this influences everything from storage and cleaning to the model choice. So keep it in mind that data quality, completeness, accuracy, consistency often matters more than the algorithm sophistications, right? So if you remember one thing, meaningful insights begin with the well understood, well prepared data, right? So here we have the real life data examples. So to make this tangible, think of an exam marks as a structured rows in a table, right? So the click streams from the mobile applications as an event logs, and online purchases as a transaction records with the product price and time, and GPS, which coordinates as a timestamp to location data. So each example which invites a set of questions which the students needs the support, uh, which the features drive up app up engagements. So what the products are frequently bought together, right? So if you are buying together any one of the product as a complementary product, so obviously if you are buying 1 liter of milk, obviously you would have buy your sugar or the coffee powder or a tea powder, something. So which is giving you the complementation for the other product that you're buying, right? So notice how the same raw data can serve the descriptive analysis. What happened. So descriptive analytics, which is nothing but what happened in the past, and diagnostic analysis, which is telling you that why it got happened, right? So the reason of the scenario, and the predictive modeling. So the predictive modeling, which is telling you that what likely can be happen in the future, and the prescriptive description. So you can take the note like what I'm telling, like I will be repeating again. So the prescriptive decision, which is telling that what to do next. So it will be prescribing you what are all the things, what are all the action items to be follow in the next, the future. So keep it on mind. The first thing is that a descriptive analytics, which is in you telling you that what happened in the future, sorry, in the history, and diagnostic analysis, which is telling you that why it got happened. Descriptive, diagnostic, predictive, and prescriptive. So these are all the four key pillars of data science. So the trick is aligning the questions to the right data and the right method. So here we have the data versus informations, where the data becomes the information when processed and contextualized. The summaries, aggregations, and valuations, visualizations that provide the clarity first. So, for example, thousands of transactions rows mean a little until you compute the daily revenue segment by the product, or compare week over the week trends, right? So information which is supporting you the decisions by reducing the uncertainty and highlighting the patterns. So, but remember one thing: information, it's not just automatically insight, right? So it may describe what succinctly, without explaining why. So you should raise why questions many times. As we move forward, we will separate these layers: data, information, insight, actions. So this progression prevents us from the stopping at the dashboard and encouraging asking the casual questions or hypothesis driven questions that lead to the real impact, right? So here we have the information versus insight. In the last slide, we gone through that the data versus information. So in the slide, we will be differentiating this information versus insight. Information which is telling you that what happened. Say churn increased, right? Churn is nothing but you have a set of customers, 100 customers last month. So you have 75 customers this month, the loyal customers. So your churn rate is 25 percentage, right? You are losing your customer. So which is nothing but it's a churn, right? So this churn, which is increased 5 percentage, while insight explains why, right? So such as a price change, or you would have changed the future frictions, or and the guides what to do next. So the goal of the data science is to create an actionable insight that influence the outcome. So think of a funnel, right? So think of a funnel. Raw logs turns into KPIs. KPI is nothing but the key performance indicators. So this anomalies triggers the investigations, and analysis reveals the drivers. So that suggests these interventions, like discounts, where to fix the discounts, where to fix the UX, as think it as an app developer, right? The front end developer, or targeting the messages as an um, digital marketer, digital marketing analyst, right? So the modern AI assistants can accelerate the explorations, but the human role where framing the hypothesis, validating the assumptions. So as you practice, train yourself to move from what to so what to what, not know what consistently, right? So here we landed up with the in the the main course of our program. So what is data science? So this data science, which is which is called as a discipline of extracting the meaning from a data to support the decision, the business decisions. So it blends the statistics for inference, programming for implementation and scale, and the domain knowledge for the relevance. Practically, which is telling you that it spans the data collection, cleaning, and exploratory analysis, modeling, and communication. So these outcomes are range from descriptive analytics and forecasting to classification, clustering, and optimization. So the common thread is using the evidence to reduce the uncertainty. So there are two key habits distinguish the effective data scientist. So first thing, the stating the assumptions explicitly and testing them. So the second thing is that closing the loop with the recommendations lead to the measurable impact. So if not, iterate it. That the experimental mindset is our north star, right? So let me ask you one question. So Ranjit, are you here?
Yes.
So can you please tell me what are all the four pillars of data science?
Uh, Directive, prescript, diagnostic, diagnostic, predictive, prescript. Sorry, 1 minute. Wait.
Yeah, yeah, yeah. That's fine.
Directive, predictive, diagnostic, prescriptive.
So the first thing is that
Pres-
descriptive, diagnostic.
okay.
Yeah,
Okay.
right. So that's a good try,
Yes.
right? And so here we have the next slide of our components of a data science. So here is the life cycle. So this life cycle, which is telling you that to collect the relevant data, which is aligned to well scoped questions. So clean it to handle the missingness of the data, outliers, and inconsistencies. So the outliers will be dealing with this jargon, which is calling it as an outlier. Outlier is nothing but it's an odd man out. So if you are facing the big data, right? If you are dealing with the big data, you cannot say that you cannot surely say that that complete data is a true one. That might be an anomalies, and that might be a wrong data into it, right? So we will be finding out the wrong data, and we will be dealing it up, and we will be solving that outlier, or we will be removing that outlier from the data set. So for example, uh, you will be measuring the heights in a classroom, right, of a sixth standard. So obviously, you can say blindly the average height of the sixth standard student is about 160 centimeter to 170 centimeter. Think it of like in the data set that what you have measured in the list, you are seeing 200 centimeter of one student, so which is not at all possible, or it should be a wrong data, or it should be treated as an outlier to remove, or you can do certain techniques to compress that data set, right? So which is nothing but it's an outlier. So outlier, which is nothing but it's an odd man out of the data, right? So skipping these steps creates a brittle solutions, right? Here we are seeing so many five techniques, right? Data collection, data cleaning, data analysis, machine learning, and business understandings. So among these five, business understanding is very much important when you're dealing with a client, right? So we will discuss simple, repeatable practices, the data dictionaries, versioned notebooks, clear metrics definitions, and validation splits. So these habits, which is keeps the projects reliable as they move from notebook prototype to stakeholders reviews and eventually to the deployments. So here we have the data science with versus data analytics. So as a common, the beginner, you will be getting some confusion. So what is the difference between data science and analytics? So analytics, which is telling you that you will be reading up, you'll be doing the storytelling, you will be creating the dashboards from the data set, and you will be merging up the tables. You will be dealing up with a large number of data from different sources, from SQL, from the Excel sheet to cloud or anything else, you will be dealing with the data. So as come from the data science, where you will be creating some algorithms, you will be creating some pipelines to it, where to analyze the data and finding out the outliers, and you will be finding out the real time insights. So that's why you are calling it as a data scientist, right? So think of an analytics as explained the past and monitoring the present dashboard first, and the descriptive stats and the trend analysis, and the data science, which is extends this by predicting the future and discovering the structure. So where this data scientist will be acting as an like a doctor, like, so what are the things that we need to do? So you will be giving you the prescriptive analytics. So as we collected from the historical data, we'll be having the historical data. So from that historical data, where what all the dots should be get connected in the business terms, right? So at the Diwali time, like say for example, you will be having you have a the clothing shop, the textile shop, right? So at the Diwali time, what are all the procedure items? What are all the action items should I take? So should I, as per the trend for the past 5 years, how many goods should I load in the godown so that the sales can happen frictionlessly, right? So think it of like how much goods, how many quantities should I buy from the the production, and we can store it so that when the salesman they can do the sales to their customer more smoothly, right? So these are all the business the action items and the prescriptions you will be telling to the business, right? So both are essential. So the data science and analytics both are essential and often overlap in the practice. So mature teams pair analytics for the situational awareness with the data science for uh, the strategic bets, right? So if you are starting out, build strong descriptive and diagnostic skills first. So they sharpen the intuition and the data literacy first, and then add the predictive methods when you have the clear target, sufficient data, and the plan to act on predictions. So here is a trendable, the topic that ML versus AI, data science versus ML versus AI. So AI is the umbrella for the systems that appear intelligent. And the machine learning, which is a subset focused on learning patterns from data. The data science is the practical discipline that uses the ML alongside analytics, experimentation, and the communication to create the outcomes. So in other words, AI is the ambition. ML is one of the method, and the data science is the workflow that bridges the questions to solutions. So this framing keeps us grounded. So we adopt the ML when it helps answer and the well posed questions with the available data. So otherwise, simpler analytical methods or the rule based logic may be more appropriate and cost effective. So here we have the importance of the data science. So this data science, the data volume and the variety are the exploding, making manual decision making risky and slow. So organizations needs the evidence-based process for the accuracy. Accuracy, not only the accuracy, readability, and the scale. So data science, which is enables that by automating the parts of the analysis, improving the forecast, and surfacing the patterns human might misses. Right. So it's also a competitive advantage. Better personalization, master pricing, proactive risk detection, and streamlined operations compound over the time. So, however, impact depends on these impacts depends on the more than the algorithms, data governance, measurement culture, and the cross-functional collaboration matters. So we will be talking about the realistic steps to create a value even with the small data set and limited tooling. So application of the data science. So here you have an experienced data scientist already, I think so. So you would have realized that the personalized recommendations on streaming the platforms like Netflix. So the customers is also bought suggestion in e-commerce, fraud detection in banking, and predictive triage in healthcare, right? To know the severity of the patient and the performance analytics in the sports, right? So in IPL, in each of the every team will be having a sports analyst to analyze the weakness and strength and do the SWOT analysis of on each and every players to know their strength and weaknesses and what all the things should be get optimized and what all the things might be a threat for the player, right? So understand under the hood, these use the classification, ranking, anomaly detection, series forecasting, and optimization. So these don't get scared with these words. So obviously, I will be teaching you these jargons in a weekly manner, right? So we'll be deeply diving into each and every concepts in data science as far as we can, right? So the pattern, which is it's consistent. So let's start with the business goal, and we can down the line we can go through the technical knowledge, right? So we will be unpack why iteration beats the perfection, right? So launch simple steps and learn quickly, and then we can scale the complexity when it is demonstrably improves the outcomes. So here we have the data science workflow. So the first thing is that our workflow, which is defines the problem first crisply with a target metric, and collect the relevant data source across the data sources and clean the data and standardize it. So explore with visualizations to form the hypothesis. Like an engineer, like do the future engineering thoughtfully, and select and train the models. So train the model in the sense we will be having a model set of models, which is pre-trained and which was pre-coded already. So you no need to code from the scratch. You can use the module in the Python library, Python notebook, so that you can develop your own pipeline into that, right? And build the checkpoints, retraining the schedules, alerting or metric drops, and the stakeholders reviews. So remember, a well communicated simple model that ships is more valuable than a complex one stuck in a perpetual tweaking. So let's dive into the data structures. What is structured data and unstructured data, right? So this structured data, which is lives in a rows and columns. Think that the spreadsheet and the SQL tables. So it is easy to query, aggregate, and visualize it. So examples include sales transactions, inventory list, or student scores. So typical steps include the handling the missing list or the values, the encoding the categories, normalizing the scales, and joining the tables. So again, I'm saying that don't get scared with these kind of words. So I will be telling you that these I'll be explaining you these words and giving you the meaningful the explanations. So once I stopped once I got stopped, you can raise some questions and you can fulfill those gaps, right? So we will be emphasize tidy data principles here. So the each variable is a column, each observation as a row, right? So think it of that each types of the observationals unit as a table, right? The clean, structured, dramatically spread, the speed ups the data analytics and the reduce the errors. So here we have the explanation for the unstructured data. So this unstructured data where you can save it as a text, images, audios, videos, doesn't fit neatly into the tables, right? So you cannot control these data into the tables. So it often contains a rich signals, but needs a specialized pre-processing. So we will be using this unstructured data too in our data science to use the predictive modeling, right? To do the predictive modeling and all. Say for example, you could have seen in Gemini or ChatGPT, if you are uploading any of the images, it will be telling you that what is about the image, right? And while harder to analyze, these unstructured data, which is unlocks the powerful applications. So it will do the sentiment analysis for the support tickets and document summarization, image classification for the defects, or voice intent detections. And the process and the approach remains the same, where it starts with the clear questions, then choose the suitable representations and the models. And hybrid data sets are the common and the combines text with the tabular metadata to improve the performance and interpretability. So let me stop it here and let me ask you the questions if you have any doubts. So Ranjit, do you have any doubts?
Uh, okay. Actually, I want to know the exact difference between machine learning and the data science.
Sorry?
So, for my understanding, i- could you able to hear me?
Yeah, Ranjit, go ahead.
Okay. Actually, for I will tell my understanding. So after that, we'll go for the answers. So for my understanding, machine learning is a overall concept. So inside there is a concept as machine learning.
Yeah,
So
machine learning, yeah.
using machine learning, we are doing some analysis. That is data science.
Yeah, we'll be doing that machine learning also. So machine
Okay.
learning, which is it's a
So
subset, right? It's a subset of a data
no, no,
science.
no.
Mhm.
I can understand difference between AI and ML, but cannot differentiate with the data science.
Okay, so you are telling
Could you
that,
please
yeah. So
yeah,
yeah, so machine learning, which is it's nothing but it's where we'll be using the algorithms. So for example,
okay,
like
okay,
where the machine learns, we'll be feeding up the informations to the machines. So say for example, you have a set of software, right? Like a chat
okay,
GPT or something, the applications
yeah,
that we are
yeah,
using.
yeah,
So this
okay,
applications doesn't know that how to generate the words next to next. Say for example,
okay, okay,
the cat sat on the mat. So how these words are getting connected, right? So how these
okay,
words are generating and giving you the meaningful message. So that might be in it's also a computer, understands only the binary digits, right? So
okay, okay,
how it can connect. So we'll be using certain algorithms like ANLTK, and we'll be using some of the algorithms to understand the missions, and we'll be feeding
okay,
up the missions with a large number of data, with the label data,
okay,
right?
okay. Yeah, yeah.
Say for example, you can find it out the image of and you can differentiate the image of a dog and cat, right? So how the machines can identify.
Okay, okay,
So yeah. So when you are uploading the image and you will be labeling it to the machines, to using some of the
okay,
software, to using some of the libraries like OpenCV, you could have heard this library called OpenCV, Open Custom Vision, Computer Vision. So this
okay, okay,
library, which was already coded by some developers, by the Python developers, so
okay, okay,
you no need to learn it, and you no need to code from the scratch. So you can use it, use those libraries into your coding or into your project directly, and you can directly move on, right?
okay, okay, okay.
So
Fine.
likewise, this libraries, how would they constructed is that if you're uploading any of the image, it will be segregating those images into pixels by pixels, right? It will be
Okay,
identifying,
okay,
okay, uh, you can know that the cat and dog have the same four legs, and the tail and the facial structures might be the similar, but how we
okay.
are differentiating it,
Yeah, yeah.
right?
Okay, okay.
So
Yes.
likewise, the machines also will learn, segregating into
Okay,
pixels by pixels, and it will get learned. So that is machine learning.
okay,
And we'll be using that machine
okay,
learning. Data science is nothing
okay,
but we will be coming up with any of the outcome, any of the business outcome.
okay, okay, okay. Got it. Fine.
Yeah, yeah, thank you.
Yes.
So
Thank you.
yeah, thank you. So coming into that's a nice question, and uh, thanks for raising that questions. So let me take you forward with that. With a nice use case. So in healthcare, this open CV, open custom computer vision, it's ready to um uh, you know uh, predict the cancer cells into the person, right, in the patient. So
Okay,
if you upload any of the scanned images, if you upload any of the
okay,
scanned images of your body, it can identify whether you have this cancer or not, whether it
okay,
contains a cancer cell. Why? Because it got trained before. It should identify these are all the cancer cells. So you should we will be training it up the machines. Once the user uploaded, you should tell that whether it has a cancer cell or not. So we will be
okay,
identifying, we'll be feeding up the data, we'll be feeding up some images, we'll be giving the labeled data to that, and we'll be asking that questions to the machines to understand and to interpret it.
okay, okay.
Yeah.
Yes.
Yeah. Thank you. So I want out 1 second. Analytics is like forecasting by using the info we collected from the analysis. But how come data analytics is about the past? So yeah, past is nothing but it's a historical data, right? You'll be dealing up only with the historical data. By that only, like you will be forecasting it using some algorithms. We'll be using linear regression and logistic regression. So by using those algorithms, we'll be able to forecast the data, and say for example, you are in Salem, right? So obviously you would have known that some of the areas like Fairlands and some of the areas uh, would more standards. They have more standards, and the cost of living will be more there. And you cannot get the rent of any of the houses below the 3,000 or 5,000 rupees. So obviously, based on those regions, you will be analyzing the rent, and you will be analyzing the rent of an area, or the standard and the cost of the living of an area. So based on the square feet and the pricings of each and every houses, let's collect the data. And if you are searching for 1,000 square feet, and you can easily able to get what would be the price of a 1,000 square feet of a house, right? So likewise, we will be forecasting the data within historical data. Did I answer your question? Yeah, thank you. So let's get back to this slide. So the first thing is that on the first day, I it's not my intention to scare you people to show the code and run away from this meeting. So I would like to stay you people in the meeting to understand the theoretical concepts first, and we can dive into those deep knowledge and the coding part later, right? The second and third day we can able to dive into that. So before that, we have to be very strong in statistics and what is the business requirements from the clients that we can have in the real-time projects. So if you wanted to switch the career, what would be the best time to get switched, right? And here we have the types of analytics. So we can categorize these analytics by questions by the answer. So the these descriptive will be you can take a screenshot of it, right? So this descriptive, which is writing raising your question, what happened. So the metrics and the dashboard, we will be dealing it out, right? And the diagnostic asks why did it happen, the segmentations, correlations, control the comparisons. And predictive, which is ask you that what will happen next, where we'll be telling you that the forecast and the classifications. And the prescriptive, which is ask you that what should we do next, right? What all the things should we do, what all the action items should be listed out to face the future crisis or something. So we can able to predict the model. Did you know that one of the member in US, he invested in stocks using ML and the data science. So he is predicted those stocks whether it is going to up or down. So based on that, he invested those stocks, those monies on stocks, and he got I guess $1 million or something. So think it in that way. We should develop the products first. So we should develop the use cases. We should fulfill those problems which is around in the society. So think of this as a maturity path. So you don't need to jump to the prescriptive immediately. So build a strong basics in the descriptive diagnostic foundations and introduce the predictive when valuable, right? And only then design the prescriptive policies with a clear evaluation metrics and guardrails. So data-driven decision. So what is data-driven decision making, sir? So data-driven decision makings, which is telling you that to reduce the guesswork by grounding the choices in evidence. So randomly going with any of the assumptions, we should have the data-driven decisions. So where it will improve the accuracy by testing the hypothesis against the real outcomes. So which is supports the strategy by quantifying the trade-offs, identifies the risk earlier through monitoring, and increases the success rates via the continuous learning loops. To make this work, define metrics that reflects the business value. and which is creating you the transparent dashboards. So we will be dealing up with the so many visualization tools like Tableau and Power BI as well. So after doing the data cleaning, data analysis, we will be jumping into the data dashboard where we'll be creating reports in Power BI and Tableau. Be using some of the DAX measures. I'll be teaching you the DAX measures as well. So where you can, which is very very crucial as a data scientist to learn all these tools. So first, you should be having strong knowledge in business requirements, statistics, and then you have to think as an the Python developer, where you will be dealing up with the algorithms, and then you will be creating Power BI dashboards, right? To present to your stakeholders. It will be more friendly to explain as a storyteller, right? So crucially, foster a culture path where it is it's a safe to change the course when data suggests a better path. So data informs, leadership decides, but with more clarity and the less bias. So here we have the role of a data scientist first here. So this data scientist where wears the multiple hats. So first he has to understand the business problem deeply and stakeholders, constraints, and the success metrics. So second, he will be working up with the data end to end, sourcing, cleaning, integrating all the data, right? So the third thing is that he has to apply the statistics and machine learning appropriately. So choosing the right methods and that fits the question and the data realities. The fourth hat is nothing but it's a communications. So communicate insights clearly, visuals, narratives, and recommendations, which is tailored to the audience. And finally, it supports the decisions by measuring the impact and iterations. So these are all the roles is as much about the questions and communication as it is about the code. So curiosity, empathy for the users, and ethical judgments are the key differentiators, right? So what are the skills required as a data scientist? So the core skills, which is includes the analytical thinking, breaking the ambiguous problem into a testable parts, and the statistics, probability for the uncertainty and the inferences. So Python, which is it's a basic and practical tool for the data wrangling and the modeling and data automation as well. And for the data visualization, which is used to translate the findings into stories, stakeholders, and it can act upon that. Domain knowledge and domain knowledge, which is ensures that the relevance and the feasibility. So the soft skill matters too, and the prioritization, stakeholders alignment, and the clear writing. Can you please be on mute if someone is unmute? Yeah. So your learning plan should be balanced, breadth and depth. So get comfortable with the data manipulation first. We'll be having pandas, NumPy. What is NumPy? I will be telling you that what is NumPy, what is pandas, what is matplotlib, what is scikit-learn, all those stuffs. And we can use those tools to visualization, and we'll be able to predict the outcomes through the classifications and the regressions. So what is classification, what is regression? So regression is nothing but we'll be dealing up with the numerical values, and this classification where we'll be dealing up with the text and as well as the images. So what is next, and so if you're uploading the two images, the model should be able to differentiate it, what is the cat image, what is the dog image, right? uh, and whatnot, like how to identify the uh, mail spam email, or it's in a normal email, right? So it has to get give some classifications and experiment designs. So I hope like you will be enjoying the one concept, which is natural language processing, and the time series, recommend systems, and the ML ops. So these are all the interesting topics we will be covering in our channel and our community, uh, as far to the depth of my knowledge. So these are the tools that we are going to use. The typical toolkit, which is Python for data analysis and modeling, and Excel for quick checks and stakeholders familiarity, and SQL for the extracting and joining the data. And we'll be dealing up with the Power BI or either Power BI or Tableau for interactive dashboards. So I will be checking you with you people to in which area you will be comfortable. So let me teach first the Power BI, and then we can go with the Tableau, right? So uh, adopt a versioned workflow first, and store the notebooks and the scripts where we'll be using this Jupyter notebook for the coding executions. So we'll be generating the charts and tables and document assumptions. So tooling should serve the clarity and the collaboration and the repeatability, not the complexity first, but also for the own sake. Myths about the data science. So let's debunk common myths. You don't need to be an engineer or an math prodigy to start. So you need to structure the practice and persistence. So advanced coding is not required on the day one. So the cleaning the data well and asking the sharp questions deliver more value than the exotic models. The field is not too difficult, right? The data science field is not too difficult. It's learnable and through the layered steps and projects. So, and it's not just for big companies. Small teams also generate the outsized impact by focusing on the right problems. So we will replace these myths with the practical heuristics, and you can also apply immediately. So let's check the reality, right? So here's the reality check where logical thinking beats the memorizing the formulas. So it's not at all, right? Learning in increments, data wrangling, visualization, simple models, then the build complexity. So confidence comes from the practice and the feedback. So ship small projects, share your work, and iterate it. So anyone can learn with the consistency, curiosity, expect the setbacks, right? Those are the most important, and they are not signals to quit, but the data points to adjust your plans, right? So keep a growth journal of what you tried, what you worked on, and what to change next. So over the months, steady habits compound into real capability. So how this class runs, right? So we will be alternate between the concise concepts, explanations, and the quick demos, then tie with them with the real world examples. So I will be invite your input frequently, short prompts, polls, or scenario questions to keep this interactive. So you will see how to translate a business questions into a data approach and how to validate the results before recommending the actions. So throughout, I will be flagging the common pitfalls and provide the checklist. You can reuse the later, right? So please keep questions coming, and if something it's not clear to you, it's likely it's not clear to others either, right? So expectation from the audience and the students to get the most from this session, bring curiosity and be active, ask questions, react to the examples, and then try to the exercises. Don't worry about being wrong, right? So make your hands dirty. We will learn faster by exploring and correcting it. So commit to the practicing regularly after this class. Small data set, and you can take the short notebooks and you can do the realistic problems. And open-minded helps you to be willing to unlearn habits and adopt the evidence first thinking. So if you can promise curiosity, participation, questions, practices, and openness, I can promise you that clarity, structured, and the support from my side. So think like a data scientist. So this would be the best outcome from the session that I can say that, right? So train your mind to observe the world like a data set. So when an app recommends something to you, what signals it got used, you can think. And when a company changes a price or consider the metrics, they are optimizing it. So identify the data behind everyday decisions, features, constraints, and trade-offs. So think logically, form the hypothesis, and imagine how would you test them. So over the time, you will build an analytical mindset that generalizes the across the domains. So this habit of a turning curiosity into structured inquiry is the most valuable asset you can develop. So here we have the session summary. So today we build a foundation. We'll build a complete foundation. What is data sciences and why data quality and why the context matters and how application across the industries translate into values. And we clarified the myth and replaced them with the realistics. So step by step, path to proficiency. So you now have the mental model for the workflow, problem framing, data handling, analysis modeling, and communicating insights. So your next step is to practice on a small but real data set. So I will be guiding you with that, throughout this masterclass. I can sure that I can, damn sure that you can handle medium size of a data set after this masterclass, right? As a beginner. So keep the loop tight and question more, test, learn, and iterate it. So thank you for your engagement, and I'm excited to see what you build next. So thanks for joining the session. And so if you have any doubts, you can shoot up the questions.
Okay. Hello.
Yeah, yeah, Ranjit.
Actually, I will introduce about myself
Yeah,
so that you can get some clarity.
yeah,
So actually,
yeah.
I studied 2017 passport mechanical batch. So I was
Yeah.
in currently having 8+ years of experience with the mechanical vehicle CFD simulation.
Mm-hmm.
So
Nice.
I want to switch to some machine learning AI and deep learning something. So
Mm-hmm.
I don't have actually don't have any basic idea. So but I have um, basic idea about Python. So Python language, I have an idea.
Okay.
So I want to know what are the things I have to do as like type of homework or self work need to move further, like for
Okay.
learning your courses, your classes or some. And also, is there any books or any courses, valid courses or any certification courses? So it will be useful for if I after some months, it will be useful for me to apply for any uh, jobs related to this career.
Yeah. So I can answer your question that you are saying that you have an prior some experience in Python. So what I can suggest you
Yes.
that yeah. So you
Okay.
can start with the OOPS concepts. So let me teach you the OOPS concepts as well. So let's start with the
Yeah, yeah, of course.
building the foundations. So what is class and
Okay.
object, and what is inheritance? What is encapsulations?
Okay.
So and after this,
Okay.
we will
Okay.
be diving into NumPy and pandas first. How to do the data wrangling, data cleaning, data optimizations. So after this, we will be jumping into the some concepts called machine learning. We'll be having OpenCV and CNN.
Okay.
CNN is nothing but convolutional neural network, and we can do the text classifications by using some of the libraries where I will be teaching you, and I will be giving you the
Okay.
codes as well. I'll be giving you the code,
Okay.
and
Okay.
I'll be driving you with the step-by-step implementations, how the code is working on, right? The step-by-step, code by code, I will be
Sure. Sure.
explaining you, right? And
Okay. Okay. Yes.
I suggest you not to take any of the courses. You can take the YouTube videos. I will be sharing some of the YouTube videos where
Sure.
will be giving you the more clarity on that. And I will be
Okay.
giving you the
Okay.
code files, and I will be giving you the projects. I will be guiding you
Sure.
guys
Sure.
through the projects. So
Okay.
only thing is that
Okay.
you
Okay.
can share these communications and channels and the meetings. What I'm sharing you to your friends to join,
Okay.
right? So we can able to build a massive
Sure. Sure.
community, and we can help some people to get
Okay.
grow on,
Okay.
right? So it will be more beneficial.
Sure.
So the
Sure.
things that I'm grateful to do it.
Okay. Another
So
question, actually, this is related to uh, the core, the core. Sorry, the motive is for data science, right? With using machine learning.
yeah.
So, I want to know about this. Actually, in my organization, they are suggesting this some kind of generative AI and agentic AI.
Mhm.
So, I want to know more about that also.
So that is a different track where we'll be having in separate classes, the
Okay.
separate sessions regarding that.
Oh,
Before,
it is different.
yeah,
Okay.
yeah, it is
Okay.
different.
Okay.
So
Okay.
I can
Okay.
share
Okay.
you
Fine.
the YouTube channel that already we took 10
Sure.
sessions
Sure.
related to Azure, right? Using the Azure
Okay.
models, how we can build up the no our old models, right?
Okay.
Old models
Okay.
in the sense like how to
Okay.
generate the text, how to build the chatbots. Those stuffs we have already
Okay.
developed it. So if you want, you can go and
Okay.
see in our channel where I will be sharing it after this recording, right? After
Sure.
the
Sure.
session, I will be
Sure.
sharing
Sure.
you that, right?
Yeah.
So
Yeah.
it will give you the more clarity on how the AI getting start, and it will be telling you that the histories of AI, how it got evolved, and what is the current position, what would be the future. All those things got recorded on
Sure.
that YouTube channel. So it will be like a playlist, so
Okay.
you can go and you can watch it.
Sure. Sure. Thank you.
Yeah,
Thank you.
yeah. Thank you, Ranjit. So, Liu, any questions? Business analytics and just now started into it. And DS and the business analytics is different, but the core are same to me. Is there any major differences? Yes, obviously. So the business analytics, which is uh, uh, you will be dealing up with the dashboards and storytelling. But when it comes to the data analytics and the data science, you will be handling up with the large data. So there will be a messy data will be you will be getting it. So uh, you will be handling those data, and you will be making it as a straight line, and you will be giving it to the data analysis team to interpret it. So they will be creating the dashboard, and the business analytics team will be will be telling the storytellings. So the main role of the business analyst is to do the storytelling by seeing those dashboards. So they will be finding out the key points and the stories. They can build up the stories by seeing the dashboards. So how this data sales trend is, and how the profit trend is. So are we reaching up to the goal? They will be building up the stories. So our duty is to make the data straight, and make the data clean, and make the data wrangling. So these are all the steps that we will be following as a data scientist, right? So our job is more technical than those people. Did I answer your question, Liu? Yeah, thank you. So thanks for joining the session. Hopefully, like we have completed the first day. So still, we have 9 classes to go, right? So stay tuned, and I will be sharing you the materials, code workflows, and the simple coding steps, right? The simple problem solving cases. I will be sharing it on the group, and I will be sharing the many of the notebooks and related to Python, related to data science, related to machine learning, so that you people can, uh, you know. Uh, do the research on your own, right? So that will be more useful. So my suggestion is that make your hands dirty. Don't get scared to do the wrong thing, right? So thank you. Thanks for joining the session. Bye. Catch you up in the next session.